guys, in this video let me explain what is finite automaton. You can call finite automaton as a finite state machine, that is FSM, finite state machine, or finite state automata, that is FSA, finite state automata, or finite automaton, or simply a state machine, which is a mathematical model of computation in theory of computation. So let me give you a mathematical definition of finite automaton. A finite automaton is denoted by a phi tuple Q, sigma, delta, Q naught, F. Here Q is a finite set of states. Q naught is in Q, that is the initial state. Q naught is the initial state, that is also one of the state in Q. Okay. So Q naught is the initial state. F, which is a subset of Q. That means you have more, maybe one final state or more than one final state. That's why we use the symbol subset. F is a subset of Q, is a set of final state, and delta here. Delta is a transition function mapping Q cross sigma to Q. So delta is a transition function mapping Q cross sigma to Q. Okay. So here for example, that is delta of Q comma A is a state for which each state Q and an input symbol A. That is the meaning of delta of Q comma A. Q is in Q, that is set of states, and A is the alphabet, that is in sigma. Okay. So delta of Q comma A is a state for each state Q and input symbol A. That is the meaning of delta of Q comma A. As I told you already, F is a final state. That may be subset of Q. That means you have either one final state or more than one final state. Actually, in finite state machine or finite state automata, finite state machine or finite state automata, whatever that may be, you can write. So here I can write FSM. So here we have two cases. That is finite automata without output. Okay. Finite automata without output. The next case is finite automata with output. The second one is without output and with output. So in without output we have two categories. That is under more emission and male emission. Finite automata with output, we are having three categories. Okay. That is deterministic finite automata, non-deterministic finite automata, and epsilon NFA. So in deterministic finite automata, what is deterministic means, that I will explain later. So here you have only one output, that is for a given input you have only one output, whereas in NFA that can be any number of output, maybe 1, 2, 3 like that. Okay. So epsilon NFA, that is the epsilon move is allowed, so that's why we have to discuss as a separate case. So epsilon NFA. So here FA without output we are having these two categories, whereas in case of FA with output we have DFA, NFA and epsilon NFA. So in such cases here we have look at the final state, maybe one final state or more than one final state. Okay. Now let me now move on to how we are going to represent any one, that is any given finite automata using transition diagram. Okay. So for every Q belongs to Q and for every A belongs to sigma, delta of Q comma A is in, that is belongs to Q, that means that is one of the states in Q. Okay. So for any state Q, if you take any input, for a state Q, if you take any input A, suppose if you take an input A that leads to one of another state, that state is also in Q. Suppose if this is Q means this is P. Okay, that is also in Q. That is the meaning of this. Okay, so finite automata you can denote this by FA or FSA. Now let me now move on to transition diagram. So one of the important diagram used to represent the finite automaton. So a transition diagram is a directed graph. Okay, so graph along with direction is given. So with an FA as follows. The vertices of the graph corresponds to states of FA. So here we can take the vertices as states. Okay. So if there is a transition from a state Q to another state P on an input symbol A, then there is a labeled A from Q to P. Suppose this is Q and this is P, okay, I am just write it here. Suppose this is Q and this is P. So if there is a transition from Q to P on an input by taking an input symbol A, then there is an arc. You can draw an arc like this with a direction like arrow like this. With an input symbol, there is an arc labeled A from Q to P. Okay, this is how you have to construct the transition diagram. So the finite automaton accepts a string. Okay, the string X may be of, for example, AB, whatever that may be. Okay, so the finite automaton accepts a string if the sequence of transitions corresponding to the symbols of X leads from the initial state to the final state. Which means, suppose if you are having a string AB, so by giving input symbol A, you move on to next state like that. After taking input B, you are in the next state A and then B. So look at the last state, okay, B. If it is the final state, okay, so after taking the input symbol B, if you are at the final state, which means the string is accepted by the finite automaton, or otherwise it is not accepted. Okay, so now let me see that in detail by taking a simple example. So the transition diagram of an FA illustrated in the following figure. So look at here, this is a transition diagram. So here I have to write down the transition function like this. So delta of Q naught comma, also I have to mention one more thing. So as a note I have to given here. So in a transition diagram of a finite automaton, the initial state Q naught is indicated by an arrow labeled start. Okay, so an arrow labeled start indicates that is the initial state. Okay, the final state is indicated by double circle. If you write down the double circle like this, and if it is any of the state like P or Q, so which means if there is any double circle like this, means that is the final state. Now let me move on to the transition diagram. So look at here. So for this one, you have both initial and final states are at Q naught. Okay, so Q naught here is the initial state and also final state. So here 4 set of states are there: Q naught, Q1, Q2, Q3. So as I told you already, so the finite automaton is a finitable. So Q is nothing but a set of states, that is Q naught, Q1, Q2 and Q3. So these are the 4 states. And what is Q sigma? What is your sigma? Sigma is nothing but input alphabet. What are the 2 input alphabet we have to take? Only 1, 0 and 1. Q sigma. Next one delta. I have given here delta detail here. So next delta, and then which is the initial state? Q naught is the initial state. Here Q naught is the initial state. How you can identify that is initial state? This is an arrow labeled start here. So which means this is the initial state, and which is the final state? Here only one final state, that is Q naught is subset of Q, isn't it? So Q naught is in one of the state in Q, and also that is also a final state. Okay, so now look at here how we are going to represent the transition function like that. Here like this you can. So as I told you already, delta is a transition function mapping from Q cross sigma to Q, isn't it? So now how we are going to write down the transition function? It's a simple method of writing is you can use this table method, okay, or otherwise, so using the definition I can given like this. So just look at this diagram. So at the state Q naught, if you take an input symbol 0, what happens? In Q naught, if you take 0, 0 means that leads to Q2. So now you are at Q2. So again at the same state Q naught, if you take the input symbol, if you read the input symbol 1, what happens? In Q naught, if you read the input symbol 1, you go to Q1. Okay, next. Delta of Q1 0. So Q1. So in Q1, so if you read the input symbol 0, you go to Q3. Right? You go to Q3. Next, if you read the input symbol 1 at Q1, what happens? So if you read the input symbol 1 at Q1, so you go to again Q naught. So that is the initial state and also your final state. Next, after reading in Q2, if you read in 0, So if you're reading 0 means you go to Q0. In Q2, if you read the input symbol 1, what happens? You go to Q3. Okay. Next for Q3, in Q3, if you read the input symbol 0, what happens? If you read the input symbol, you go to Q2. Okay. And 0 means you go to Q3, 0. That means you go to Q1. And also Q3, 1 means you go to Q2. Okay. That's all. Now, instead of doing like this, I can do a very simple way for a clear understanding of this transient function. So, the input symbols are 0, 1. What are the states here? Q0, Q1, Q2, Q3. Okay. This is the input symbol. Isn't it? So, in state Q0, if you read 0, what happens? In state Q0, if you read 0, you go to Q2. In state Q0, if you read 1, that you go to the next state Q1. Next, in Q1, if you read 0, what happens? If you read 0, you go to Q3. And in Q1, if you read 1, you go to Q0. Next, in Q2, if you read 0, means in Q2 what happens? You go to Q0. And in Q2, you read 1, what happens? You go to Q3. In Q3, if you read 0, what happens? You go to Q1. If you read 1, you go to Q2. So this table gives you clear insight about how the transient function moves by taking input symbol from any one state to another. Okay. So next one. Now, as I told you already, a string. So when we say a finite automaton accepted a string, so this definition gives you a clear idea about that. A string X is said to be accepted by a finite automaton M, that is a phi tuple Q sigma delta Q naught F, if the string X may be of anything, okay, like A square, A, B, or it may be in terms of digits like 0, 1, 1, 0, 1, whatever, maybe in terms of letters or digits, whatever that may be. So if delta of Q naught comma X is equal to P for some P in F, here what is F? That is a final state. That means the sequence of transitions after reading these alphabets leads from the initial state to the final state. So after reading all of this, you are at the final state, means that string is accepted by the finite automaton, or otherwise it is not accepted. Okay. Based on this, we will see one more example. So before that, let me explain how, when we say language is accepted by a machine M, so that is a language accepted by M, that is denoted by L of M, that is defined to be a set, that is L of M is equal to set of all X such that delta of Q naught comma X is in F. That is one of the final state, right? So now let me move on to the same problem. Okay. So now I am going to explain how, when we say a string is accepted by a automaton and a language accepted by a finite automaton, right? So consider this transient diagram. So the same one I have to take here. So here Q is nothing but set of states Q0, Q1, Q2, Q3, and sigma is an alphabet 0, 1, and F is nothing but a Q0 alone, because here we have only one final state and also the initial state also here Q0 2, right? So then the transient function delta is given by, as I explained already. So instead of write down the transient functions, you can write down the transient states, that is like this. Okay, this will be simple, right? Now what I am going to explain here is, here the FE accept all strings with even number of zeros and even number of ones. Okay, suppose here I have to say, here the finite automaton accept all strings with even number of zeros and even number of ones, or otherwise it is not accepted. Now let me check. So let me take a string X is equal to 1, 1, 0, 1, 0, 1. So this string consists of even number of zeros, that is it has 2 zeros, right? 2 zeros and 4 ones, both are at 2 zeros and 4 ones, which means both of them are at even number. Let me check whether the string is accepted by this finite automaton or not. So here I have to write, so what is the transient function? So gives you the answer. So delta of Q0 comma Q1, that means here I have to draw the diagram for your understanding. Q naught. So now let me move on to the diagram and I will explain. So here what is the string we have to take? 110101. So look at here, 110101. So this is the string we have to take, and let me check whether this string is accepted by this finite automaton or not. So for that, now what I am going to do is, so let me first read the symbol 1. So if you read 1, what happens? Initially we are at Q0. If you read 1, you go to Q1. Okay. So after reading 1, you go to Q1. Next, in state Q1, you have to read again 1. If you read again 1, what happens? You return again to the same state Q0. Next, in state Q0, now you have to read 0. If you read 0, what happens? You go to Q2. In Q2, you have to next read 1. In Q2, if you have to read 1, what happens? You go to Q3. Okay. So in Q3, what you do? Next you have to read 0. In Q3, if you read 0 means what happens? You go to the state Q1. In Q1, now you are going to read the next one, 1. After reading the input symbol 1, what happens? Now you are at Q0. So after reading 1, now you are at Q0. That's all. So look at the state Q0. Is it the final state? Yes, Q0 is the final state, which means the string X is accepted by the finite automaton. This is how you can check whether the given string is accepted by the finite automaton or not. Okay. So instead of doing like this, here I have to give you a transient function. Okay, how it moves. Okay. So instead of looking at the diagram, so I just write down the transient function method. Okay, that gives you a brief idea about how the function takes the input symbol and go to the next state. Okay, so now if it is in Q0 1101, so initially we have to take first 1. So if first it reads 1. So if it reads 1 means what happens? I will explain this. Okay, listen carefully. Delta of Q0 comma 1 means you are at Q1. Okay, so Q1. So next Q0 comma 1. So delta of Q0 comma 1 means Q1. So in Q1, what happens? Again you are going to read 1. If you read 1, what happens? You go to Q0, right? Next, you have to take next one. What is the next one? The next number is 0. So 110, 110. Now, delta of Q0 comma 11. This is nothing but already we have calculated. That is find out. That is nothing but Q0. So delta of Q0 comma 0. What is your delta of Q0 comma 0? That is if you read the symbol Q0 at the state Q0, you have to move on to the next state Q2. Next, you have to add one more next digit, that is the next symbol, that is 1. So delta of Q0 comma 110. After reading this, you are at state Q2. So in Q2, if you read 1, you move on to Q3. Next, you read 0. So after reading these 4, you are at state Q3. So after reading, that is the input symbol 0 in Q3, you move on to Q1. Next, last one. So now after reading all these, now you are at the state Q1. So in Q1, if you read 1, the input symbol 1, what happens? Now you are at Q0. Q0 is the final state. Q0 is the final state. So which means the string is accepted. Okay. So Q0 is the final state, so that the string is accepted by M. That's all. Similarly, the string with any even number of zeros and even number of ones is accepted by this automaton, you can verify. Okay, any string that has even number of zeros and even number of 1 is accepted by this automaton. So you can write L of M for this too. So L of M, that is language accepted by this automaton, is nothing but set of all strings, that is X, such that X is a string with even number of zeros and even number of ones. Okay. So in my next video, I will explain what is DFA in detail along with the examples. If you like my video, subscribe my channel for more videos. Thank you.